Hello and welcome to another video with Cloud Solutions Tech. In today's video, I'll dive into the world of cloud network by deploying a secure and scalable three-tier application on AWS using Terraform. Whether you are building for deployment, testing, or production, this guide will walk you through each step to get your infrastructure up and running. So what is a three-tier architecture? A three-tier architecture is a common setup for building scalable and secure applications. It consists of three layers: the presentation layer, application layer, and database layer. This design allows for better security, scalability, and management. In this project, I'll be setting up a three-tier VPC on AWS, complete with public, private, and database subnet. So this configuration will include NAT gateway for secure outbound internet access from private subnet, ensuring that your instances remain protected while still being able to communicate with external resources. So key features of this video: secure and scalable VPC with NAT gateways, segregated public, private, and database subnet, and then also automated deployment using Terraform. So prerequisites for this video: you need to have understanding of AWS, have some understanding of Terraform, and then also AWS CLI. So because for you to be able to complete this video, you need to create an AWS account, you need to download Terraform locally, and then you need to install AWS CLI, and then also configure the AWS CLI with your credentials. So I'll be putting the GitHub link in the video that will help you with everything that you need. So the GitHub repository is right here. So this link, you can use this link to create an AWS account if you don't have one, to download Terraform, create your AWS, configure your AWS CLI. So I'll make this link available. So all the files that we will need to deploy a secure three-tier AWS VPC application, we already have everything here. I've created here in the repository. So what you just have to do, you just have to clone this repository to have access to all this Terraform code that we have here. So I'll make this repository available. I'll put the link. So you just clone the repository and then you have the code available. So in my case, I already cloned the repository. So I have everything right there that we're going to use to create the VPC that we want to use for this project. So I'll just break down each and every one of these files one after the other, and then we'll go ahead and create our VPC. At this point, let's take a look at the Terraform configuration files that make up our project. We'll be going through each of the files one after the other. So the first file I want us to look at, let us look at the versions.tf file. So let me cap that file. So the purpose of this versions.tf file specifies the required Terraform version and provider configuration. So this ensures capability with the required Terraform version and the AWS provider. So this is what this file is doing right here. All right, so let's go to another file. Let's check out the output.tf. So in the output.tf file, basically what this Terraform code right here is doing is that it defines the output to retrieve information about the created resources. And then with this, you can easily access critical information such as your VPC ID, your subnet, your NAT gateway, and then your IPs. So I'm just trying to make the video short as possible. So that is why I've already made all the codes available in the repository. I'll make it available for you to be able to use. So the next file that I want us to look at, let's look at the locals. So this file, the purpose of this file, define the local values for reusability. So it centralizes commonly used values and tags for better consistency. So basically that is what this file is doing. And then we also have another file here. Okay, let's look at the terraform.tf verse. All right. So the terraform.tf verse, it contains specific values for the configuration. So we use this to customize the setup based on the environment, the region, the business division. So maybe probably you can see right there, maybe probably you configuring it for production or for staging or for dev. And then you also specify which region, maybe probably you have a division at your work, your organization that you want to do for me, you're probably admin, HR, or whichever. You can use that to configure that part. All right. So let's also look at the variables.tf file, which is a very important file. So let's quickly look at what we have in our variables. So the variables.tf verse defines the input variable, which makes the configuration flexible and adaptable to different scenarios. So that is what that is doing. Another one that we have right here, we also have the VPC module.tf, VPC. All right, so the purpose of this VPC module is to configure the VPC module itself. So basically to set up the VPC, the subnets, the nav gateway, and then the tags using Terraform AWS module VPC for AWS. So that is what this is actually for. So we can look at it, you see all the configuration going on there. So when I'm writing my code, I like to add comments to it. So for you to know what exactly is going on. So you can see right here, VPC module configuration. So you can see right here, configuring the VPC, and then the basic details, the CIDR and so on, and then the database subnet configuration. So you can see right here. All right. So let us now look at, since we've looked at the VPC module.ts, so let us look at the VPC variable itself. So right there in these VPC variables, so we can see everything right there. So don't get it twisted. So the VPC module.tf, it configures the VPC module. So the VPC variables.tf define VPC specific variable that tailors the VPC setup, including the CIDR block, availability zones, and subnet configuration, and so on. So this is what we have right there, and you can see the IPs for the subnet, the IP for the VPC, the region. You can see the public subnet right there, the private subnet, and then the database subnet. Once we deploy our configuration, we'll be able to see those resources once they are created. All right. So vpc.auto.tf verse. So let's cut that file and look at that as well. Okay. So vpc.auto.tf verse. All right. So what does this file? What does it do? So the purpose of this file is to automatically load variable files for the VPC. You can see all the information right here, CST, VPC, class solution, VPC. So you can see the availability zones, the IPs that the public subnet will be using right here, the IPs that the private subnet will be using right there for the database subnet. You can see that also the NAT gateway and the rest. So that is what we do with that. So, all right. So at this point, you can go ahead. So at this point, I believe you should have cloned the repository already, so you can have access to all these files that I have showed you just above right here. So Terraform configuration, everything I will need is already in this file. So I'll make the link available. So just clone this repository, you have access to all those files. All right. So once you have access to those files, So the next thing now, so at this time, let's run Terraform init to initialize the Terraform to set up the backend and the provider's plugin. So I'll say Terraform init. So we'll wait till Terraform finish initializing. All right, that was successful. So the next thing for us to do is we're going to run Terraform validate. So always run Terraform validate to validate your configuration to catch any syntax error or potential issues. So let's run Terraform validate. See, all right. So Terraform validate return success. So for me, after running Terraform validate, as you can see, return success. I always like to run Terraform format, which is Terraform FMT. So Terraform format FMT is a command in Terraform that automatically updates your configuration in the current directory, for easy readability and consistency. It's a good practice to run Terraform format before committing your changes to version control, or sharing your configuration with others, or using it to configure your infrastructure. So it's just a good practice. All right, so let's run Terraform format. Okay, that's good. So the next command we are going to run now, we are going to run Terraform apply. So to generate an execution plan to see what Terraform will create and then modify or destroy. So let's create Terraform plan. All right, as you can see right here, Terraform is going to create 25 resources. So the 25 resources that Terraform is going to create, let's go through them one after the other. So let's break the Terraform plan. Let's break it down one after the other. So let me scroll up. All right, so the first part that we have here, we can see module.vpc AWS DB subnet group. So what this first part is going to be doing, so this will create a database subnet group, and the name of the database subnet group is going to be admin prod CST VPC. So the group is tagged with name, environment, and then the owner, right? So if we can look at it right here, so the tags that we have here for this subnet, you can see the name right here, the environment is prod, and then the owner admin. You can see all the tags right there. So these are the attributes setting up for the production environment managed by the admin. All right, and then it also defines a group of subnet in your VPC specifically for the database instance. So this is what this first part is going to be creating. So we can see what this first part is going to be creating. So coming to this side, right, coming to this part right here, which is the module.vpc AWS default network ACL. So this part right here, a default network ACL will be created for the VPC, also using the same name, this name right here, it admin prod CST VPC default, using that name. And then we also have for the environment is prod, and then the owner, we have admin, and then coming down here, we have the egress, and then we have the ingress. And then the next part, we move to the route table. So the route table right there, so this creates a default route table for the VPC. So that is what this part is doing. So it's creating a default route table for the VPC, and then it ensures that the VPC has routing logic defined, including the routes that will be specified later. So the route table is tagged to match the environment and then the ownership convention. We have the security, which is the default security that will be created. So the default security group for the VPC will be created. Then right here, we have the elastic IP. So this elastic IP, so an elastic IP will be allocated and associated with the NAT gateway. So the elastic IP is critical, for instance, in the private subnet to access the internet via the NAT gateway. So as you can see right here, so the elastic IP will be created in this block. And these are the tags for the elastic IP. So moving to this part right there, so in this section, we'll be having our internet gateway created. So an internet gateway will be created and then also attached to the VPC. So this allows the resources in the public subnet to access the internet. So that is what it will be doing. It will be attached as well to the VPC. And then right here, we also have our NAT gateway. So the NAT gateway, the purpose of the NAT gateway, so the NAT gateway right here is created to allow private subnet instance to initiate outbound internet connection. And then also the NAT gateway will be associated with the elastic IP that was created earlier. So the elastic IP that will be created here, so it will be associated with this NAT gateway right here. This right here. So we have the private NAT gateway that directs private subnet traffic to the NAT gateway. All right. So that's it. You can see right there the route table for the private. So the database subnet for the instances that require database access. And then we have the private subnet for the internal services that do not need direct internet access. And then we have the public subnet for resources that need direct internet access. So each subnet is tagged for easy identification and management. So specifying their types like database, private, or public, and their environment. Then we can see the changes. We can see our output right here. So you can see the availability zones that we're going to be having. We can also see our CIDR block of our VPC right here. So at this point, I believe we are good. So we'll go ahead. If you look at your changes, you believe everything is, everything is correct. So at this point, we'll go ahead and run a Terraform apply. So you can run a Terraform apply, or for someone like me that likes to use Terraform apply auto approve. So when you use Terraform apply auto approve, it's just like an alternative, right? So you can bypass the confirmation step by using the auto approve. So instead of you have to type yes, answering that question, you just auto bypass. But just make sure that you've looked at your plan properly, just the way we have looked at the Terraform plan thoroughly, to go over everything one after the other. So once you believe everything is good, so you can go ahead and run Terraform apply. So let's do that. Terraform apply dash auto dash approve. All right. So now we are creating our resources. So this will take a little bit of time. So I'll pause the video. When it's done creating, we can go into AWS to go and verify. And after we finish verifying, we can now go ahead and then destroy our Terraform. So Terraform has finished creating our infrastructures. So we can see the availability zones that we have. So we have US East 1A and B. So this is the IP, the NAT public IP right here. And then also private subnets. Those are the subnet ID. The public subnet ID, we have it right there. And then the VPC CIDR, and then the VPC ID right here. So let's go into AWS to validate all these resources. VPC. And then let's go our VPC. So as you can see, make this small. All right, so we can verify. So as you can see, we have a new VPC right here called admin prod CST VPC. If you look at the VPC ID right here ending 4ACD, You can see it matches the VPC that our Terraform created for us. And we can also see the CIDR right here. That's the CIDR block. Alright, so let's go and check our subnets. We check the private, we check the public, and then the database subnets. So let's sort it out like this. Alright. So here you can also confirm that our subnets they were created. So for the private subnets, right here we have, so we can see our private subnets right there. You have the two private subnets. The same thing with the output we have in our Terraform. That's it right there. And then if you also look at the public subnets, let's click on that and go back to what we have in our outputs. This is our public subnet right here. You can see they also match. And then we also have database subnet right here. And then we can also confirm route tables. So let's look at our route tables. So you can see our route tables that was created for this project. You can see them right here. So we have the admin, fraud, CST private. We have the default, we have the database, and then we have the public. So we created multiple route tables as we could see in the Terraform plan when we're going through it. And then also the internet gateway, we've created just only one internet gateway. You still have the same tag right here. So if you go to tag, you can see all the information. And then we also create an elastic IP, which is that right there. So let's also confirm the elastic IP. You can see the IP. It also match what we have in the Terraform. And then this is our nav gateway right there, which was created as well. So it's also having that same IP right there. So you can go ahead even still check the NAPOs. This is the NAPOs that we created. We created the default NAPOs. You can also go to security group and we see our configuration in the security group right here. All right. So you can see this is very cool. So we have checked everything one after the other. We've verified the VPC, we've verified the subnet, we've verified the internet gateway, the public route table, the private route table, the NAP gateway, and the elastic IP, the database subnet as well, and then also verify the tags. So the next step, once you are done, is for you to clean up. So that is what we're going to do then. So because it is important to clean up your AWS resources to avoid unnecessary cost. So to clean up is very simple. All you just have to do is just run a Terraform and destroy -auto-approve. So whichever one, you can run the Terraform destroy command to tear down the Terraform infrastructure and then confirm the execution by typing yes, or either use the auto approve. So you can also use the auto approve flag to automate the process without having to do the confirmation. So that's what I'm gonna do. So approve. All right, so destroy the Terraform. All right, so while that is going on, that is the end of our video today. So, and that's a wrap. So it is essential to underscore the significance of meticulously reviewing the output from the Terraform plant command. So this output serves as a critical preview, allowing you to anticipate and understand the changes that Terraform will enact upon your infrastructure. So it's important to remember that these are just potential changes. So the actual modification will only occur once you execute Terraform apply. So take your time to thoroughly examine the plan output. Not only helps in avoiding unintended changes, but also ensures that you maintain control over your infrastructure. You can see how I took my time to go over each and every of those plans before we run apply. So each resources defined in Terraform configuration plays a pivotal role, and then understanding these roles is fundamental to managing your environment efficiently and securely. So as you move forward in your DevOps journey, consistently applying this practice will help you build more reliable, scalable, and maintainable infrastructure. So you can see with just one push, we're able to create an entire VPC. That is the power of infrastructure as a code. So thank you for following along, and I hope that this tutorial will provide valuable insight into creating an AWS VPC using Terraform. So don't forget to like, share, and subscribe for more content on cloud infrastructure and automation. Thank you. See you in the next lesson.